community have gathered plethora of resources on how to clear exams like JAM, JEST, or CSI or NET. But the question always remains, is it enough to progress in physics as a career? Well, obviously no, because the exam preparation does not involve each and everything. So that brings the inception of this meet. That is, to aware us about a world which is outside exams. Basically, what research is, what does it take to develop the necessary skills to excel in our physics. We can talk about great physicists who have done this so far, like Newton, for example. While he was self-studying physics, he developed calculus, which was required at some moment of his studies. We can talk about Einstein, who did the same with SR and GL. So with that thing in mind, we present you this meet, where we would like to discuss all the nitty-gritty details of self-studying. So, moving on, the structure of this session is very simple. We have gathered a list of questions which our panelists would be discussing upon. Well, if you do not find it exhaustive enough, we have got you covered. You can always pin down your questions in the chat box, and our hardworking moderators will skim through and pick accordingly. So now the basic outline of this meet is clear. I would like to introduce our panelists. We have Bhavya Bhatt as our first panelist, who has done his BTech in computer science engineering from IIT Mandi. His major research interest lies in quantum gauge theories, primarily geometric and non-perturbative aspects of it, and mathematical physics. Then we have Chintan Patel as our second panelist. He has done his BTech in mechanical engineering from PDEU Gandhinagar. He is currently enrolled in integrated PhD course at Department of Theoretical Physics, TIFR, Mumbai. He is mainly interested in black hole information paradox, quantum gravity, and string theory. Then we have Ganesh Lakkaraju as our third panelist. He has done his BTech in electronics and communication engineering. Then he has completed his MSc Physics from Hyderabad Central University. He is currently enrolled in PhD course at HRI, Prayagraj. His research work is mainly focused on quantum information theory. We have our fourth panelist as Soumya Das. He has done his BTech plus MTech from electronics and communication engineering. He is currently enrolled in PhD at Indian Statistical Institute, Kolkata. His major work is focused on quantum information and computation and entanglement theory. Last but not the least, we have Vishal Suryanarayanan, who has done his BE from mechanical engineering. He has completed his MSc from BITS Goa and is currently enrolled in MPhil at TIFR Mumbai. His work is mainly focused on characterization of crystals and crystal growth. So, panelists, I would like to request you to send some audio or video signal like a hi or wave a hand to all our audiences so that they could realize that, yeah, this is real. We all giants are philosophically really present here.
Hi, everyone.
Hello.
Yeah, I am audible?
Yes. Very, very clearly.
Okay. Thank you.
And so all our panelists are here, I guess. Okay, so with that warm and enthusiastic start, I would like to introduce you to other members of our team, namely moderators. We have Tasmi, Ayushi, Sumedha, and Jayesh working behind the screen, and whose hard work has resulted into this meet. Then I am your host, Adesh. I am a BTech in mechanical engineering and is currently preparing for MSc entrances. Then, not to mention, we have our omnipresent Dushyant Hedata, who is the founder of our cause community. Hi, Dushyant. Is he here?
Hi.
Yeah.
Yeah. Hi.
Okay. So, in the meantime, our humble moderators would be presenting the links of our previous meets, the link of the group, through which you can connect with us. And to all the futuristic citizens of science who would be viewing this on YouTube, don't worry, all the links would be posted in the description box down below. So don't forget to check that. So without any further ado, let's write the non-inertial frame of your curiosity and open today's Pandora's box. So here we go. We have our first question, a very pretty common question which is very frequently asked before starting any textbook, before starting any kind of self-study. Like, how do you set goals? That is, how do you set a schedule of self-studying any textbook with a non-exam oriented purpose? So, Bhavya, what do you say about this thing?
Okay. First of all, hello everyone. So about this question, first of all, it depends on at what level of physics you are interested in. For example, if you are a beginner, then most probably whatever topic in which you are interested in would be having a YouTube playlist, right? And so when you are interested in viewing lectures, then it's automatically it's a much more systematic format which you have already been provided, like a YouTube playlist. And so you can set a goal, like for example 1 video per day or 2 videos per day, depending on the subject. So it's again it's much more straightforward in the video lectures format. But as you progress in your studies, less and less YouTube lectures are available on the subjects in which you are interested in, and then you have to read more and more books and other papers and so on. So for that, what I had written down is that first of all, you pick any book and you first quickly go through the book, and just in few days, like 2 or 3 days, just get a sense of the book, like at what comfort level you are with the book. For example, typically what time is it taking you to complete 1 page or 2 page and so on. So that means for few days, 2 or 3 days, you just do that. And depending on that, you set your goals, your next few goals, like I would be covering one particular chapter in this many days, depending on some linear relationship, okay, which we all have been doing for long. So for that, we can do that. Now, once you have completed a particular topic from one particular book, then you set much more bigger goals. For example, whatever topic you are interested in, you study it from different other books, okay, so that you get a much more breadth-wise perspective of what all is there. And for that, you now tend to set much more tighter goals as you previously set, because you also have to progress in your study. So I think that and along with your personal taste, you can do that. And yeah, other panelists can also add their views. Thank you.
Yeah, that covers the most of it, I guess. Still, I would like to ask Ganesh, would you like to add something to it? Sorry, Ganesh, your audio is not audible.
Can you hear me now?
Yeah.
Okay. So I'll tell you the perspective which I usually follow. That when you are studying something new, when you want to study something, a new topic, that usually happens for me when I am trying to solve a problem. For example, I mean, it didn't much happen in my MSc, but in PhD it happens it happens very regularly. That you want to learn something, that is, there is a problem in hand. So that problem in hand will set a definition of what you need to learn in certain topic. For example, you want to learn complex analysis. Complex analysis in itself is a self-sustaining huge topic. You can't learn the entire thing, at one go. You need to set a goal according to the problem in hand, and then push through and set a textbook or lecture series or whatever resources that are available according to the problem as the center. Then, because the problem drives you, you have to finish the paper, so you will eventually learn it. So that is the way I think one should set a goal.
Yeah, that altogether puts a different perspective on this. I would also like to ask Vishal if you have anything to add to it, to this.
really, you don't have much. Like I would go with Ganesh because that's how you really learn one particular topic by setting goals according to the problem. Otherwise, you don't learn in depth.
Yeah. Thank you, Bhavya, Chintan, and Ganesh. Moving on to our next question. This is a question which was set with a theoretical point of view in mind. So here it goes. Like while preparing for competitive exams or during our semester work, we come across many concepts and theories which are usually given in appendix and which are not required to study much at that moment because it is on the higher difficulty level and there is some time constraint as well as per our schedule. But they seem to be beneficial in the long run. From research point of view, they seem to be beneficial. So I would like to ask you, how do you manage such topics? To give you a direction about where I'm taking this question in, let me take an example of legendary polynomials. This is a topic which we come across while studying multiple expansion in electrostatics. So like I have studied Griffiths, and in this book they have not given much focus on this topic, and they have included this in like appendix, and the author really asked us to skip it at the moment just so you do not break the continuity. Similar is the concept of error function, which we come across in Gaussian integral while studying quantum mechanics. So I would like to ask Chintan, what do you say about it?
Hi. So if it's like you are preparing for competitive exam and you are just focusing on that subject, like as you have given the example of Legendre polynomials, then I think whatever is given in Griffiths, they define the Legendre polynomials as the expansion in whatever expansion you get from the multiple expansion, right? So, but there are various definitions where Legendre polynomials appear. Like there will be some differential equation where they appear, or they appear in some spherical symmetry or something like that. So I would suggest that actually you should go through it in some standard book like Afken and Weber, or maybe Mariel-Bose or something like that. So to get a perspective, but if you are actually preparing for exam and like there are time constraints, then maybe you can skip it for now and you will surely encounter these problems in future. And also like mathematical physics will be there as a syllabus in exam, so you will encounter these concepts really in future. So yeah, that's all.
Ganesh, would you like to add something to it?
Yeah. Okay. So this is something that will bother you whenever you are going through a very comprehensive textbook. There are many textbooks that do a job that are not catered to either undergraduates or graduates or someone. It's just that guy wants to write a book and he wrote a book. So that kind of text gives you this anxiety that I'm missing out on stuff. That will happen wherever you are, and this line that which are not much required to study at the moment, but they seem to be beneficial in the long run, that list is too big. Okay. For example, when you are studying a certain concept, like a concept, any general statistical mechanics, let's suppose, if someone asks you to derive the grand canonical partition function, let's suppose, you can't do that stuff. Okay, it comes with its own restraints, and it comes with its own stuff, and it has a different background. You have to learn what is necessary for you right now. Unless you are so curious, you're obviously curious, that's why you're doing physics, but so curious and have enough time on your hand, then you go after it right away. But never develop this anxiety that you are missing out on stuff. Because the point is, when you are doing PhD, there is no problem that no research topic that you will do. Like, I'm done with MSc. Yeah, right now I'm sitting down. I'll compute. I'll write the paper and publish. No, you'll always go back to an MSc textbook and read the stuff that you left out. That will always happen. So if you're curious enough, yeah, fine, go ahead. Yeah, and have time beside your assignments, your internships, your applications, your exams and other stuff. Go ahead, read it. But never develop this anxiety that you're missing out on stuff. That is like putting too much expectation on yourself. Okay, so as long as you're curious, you'll always learn it. As long as you're having a research topic and because you have to finish the thing, you will learn the relevant stuff. That will happen. That is a process of doing research. So it's okay. I mean, be curious, but don't be anxious. Okay, that will first of all eat you up. Okay, and I've seen many of my classmates who go through this rabbit hole and suddenly one day they are studying quantum field theory and tomorrow they are reading about killing vectors and their derivation. That's in an MSc. That's a bit much. So, I mean, I'm not offending anyone who studied killing vectors right now, but that's the point I'm trying to make. Okay.
Yeah. It certainly seems so that that kind of anxiety kills harder than the curiosity. So, anyway, moving on to the next question.
Yes, I would like to add. So, point like here in that question, you have specifically mentioned that it's given in appendix or something. So I think if it's given in appendix, maybe you should have a look at the appendix, because appendices in the books are mostly self-contained. Like you can go through it. They are not at so much difficulty level that you cannot go through it. Otherwise, they wouldn't have been given in the appendix. So if it's given in appendix, maybe it's a good idea to have a go.
So basically, what we need is to relearn and change our Indian education system habit, which we have been taught like do the chapters and skip the appendix. At least I have been taught like that, so yeah, I need to change it. So moving on to our next question, which is like what learning method should be followed while studying a topic for the very first time? Should we take each and everything, including postulates and theorems, with a pinch of salt? Should we doubt it? Should we like not take it as fluidly as the author demands it to be? For an example, like I was watching R. Shankar's lecture, and he told about this concept that we assume that the structure of atoms on Earth and stars are assumed to be the same. Like a chlorine atom on Earth would have the same composition and structure and energy if it is on a distant star. So this is a very basic assumption, but has no solid background or proof related to this. So these kind of postulates should be taken lightly, or we should go with the flow as science demand us to do with these postulates especially. So I would like to ask Soumya about this. What do you say about this, Soumya?
Yeah, hello. Others, I'm audible?
Yeah, very clearly.
Yeah. So, first of all, trust an organizer and all the participants. So, let me go to the straight to the point that, yeah. So, the question is, what the learning method should we follow? So, basically, I'm from an electronics background, and I am now doing PhD in computer, quantum information and computation. So, for me, studying a new topic, which first of all comes to mind, the motivation. Why this topic is so much interesting? Why should we learn this topic? And I came across a good lecture of quantum mechanics, which is MIT 8.04 Quantum Mechanics by Alan Adams. You can go through his lecture. So what he started with a very beautiful example. He started with a very beautiful example and motivating example that why classical mechanics cannot explain everything, some of the phenomena, and we need some alternating phenomena. Right. And that alternating phenomena is quantum mechanics. But he told that this is not the correct. This may be correct, may be not, but this explains what classical mechanics cannot. Maybe there are other theories which also can explain. So, while learning any topic, we should first set a clear motivation that why I am learning this topic. Then every time you read that topic, every time you go through that topic, you have that motivation. Okay, it is because I am learning this topic. Else the topic, after some days, after a few weeks, the topic becomes boring and you lose interest. And once you lose interest, so it's not good to it. Right. So this is and the other thing that postulates and each and everything, should remember everything with an example. So example is very important. With every postulate, if you have a example in your mind, then you don't have to remember each and every postulate. You have to just remember the example. Oh, this is the motivation and this is the example, and that's why I have came across this. Like, so I would like to add some point that when Richard Feynman was about to discover his theory with his quantum, I forgot the theory. So he told that in his book that while I was observing a spinning of the cup or the plate, so this example was in his mind, right? So this is a very good, this is what I follow to learn a new topic, that the motivation, number one point, the motivation reading this topic and the example, right?
Yeah. Very nicely put answer. Bhavya, would you like to add something to it?
Yeah. Am I audible?
Yeah.
Yeah, as Soumya said that you should have enough motivation to why you are doing the topic. But after once you have the motivation and why you know why that kind of topic is important in whatever field you are interested in, then obviously this question is very broad, and I will tell you what I follow at this point of time. That I quickly take everything on faith what author is saying and see what it is building, what story is he building, and what that story is leading us to. What new results we are getting from whatever story he is building, right? Quickly do that. Don't question every step or so on. Just quickly absorb everything and just see what we are lead to. Once you are at that stage and you have seen what, for example, if you are building statistical mechanics from scratch, you will know that at one point of time you will get a partition function from which you can derive everything about thermodynamics, right? Mm-hmm. Now, what you have at this point you have seen is that you have seen the motivation which Soumya was telling about. You have seen a second source of motivation about why this story was built and what it is leading us to. Now, once you have got at that stage, you trace back it. Okay, you track back to what all assumptions we used in building that story. Okay, and then what you do is you don't just use one particular source, one particular book or so on. You refer many sources so as to get a wider perspective, a breadth-wise perspective, as I said previously also, a breadth-wise perspective about why these assumptions are necessary, or what you say as axioms or hypothesis in a theory, why these were important in building the story. Okay, and this way you get this kind of an iterative process of learning a topic. As I said, that physics is very broad subject and you cannot really learn it in one go, right? So I think that this method works for me, that while you do iteratively or back and forth about this kind of thing, you get to get into more deeper details of the subject. For example, for the first time, if you learn path integrals, you will be doing it in 2 dimensions, one single particle path integrals. Then you move on to multi-particle path integrals. You reach a stage at which you also explore what are coherent path integrals, and why coherent path integrals are important in many body systems and so on. So this is an iterative process. You cannot really do it in one go. So first you accept this thing that physics learning is an iterative process, and then once you go about learning a topic, you according to me it fits best for me that you first quickly learn a topic and then you iteratively, and this iteration can be discontinuous also. So for example, if you learn statistical mechanics for 1-2 months and then you start doing something else, and then you get back to the same topic few months after that, and then you are again doing that kind of activity. So yeah, that
okay, yeah, that is quite an exhaustive answer. Ganesh, would you like to quickly add something to it?
Yeah, I mean, I'm going to be Steve Jobs, both steal Bhavya Bhatt's answer and say it in a poetic way. That is, you can only connect dots looking backwards. That is, once you that he made a very nice point that you can only learn first. Do not take things, especially postulates, with a pinch of salt. That means you are doubting the postulate. That kind of sows a bad seed in your head that there may be something wrong with this. Accept the postulate, learn the consequences of the postulate, and then understand why this guy made this question. For example, in case of let's speak quantum mechanics, that must be familiar with everyone. The postulates of quantum mechanics, when you first read them, they seem pretty abstract, because you're not familiar with the formalism of trying to understand expectation values as values. I mean, you learn from since your birth, even if you're not a physicist, your senses are built on the fact that you do classical physics. You throw a ball, it'll drop there simply. But that's not how quantum mechanics works. It's it depends entirely on probability distributions. So, first understand, accept the postulate, and then understand the consequences. Then try to go back and see, why this is working and why this makes sense for you. Okay, not always postulates are. If we're able to derive it, they wouldn't be postulates. Okay, they had to be done so that you have to build a foundation upon which you can build everything else. Okay, and second thing, this is another perspective on this is when you're first learning a topic. Because you mentioned this word first time, I'm telling you this. Never make opinions of a topic just because you had a bad teacher or a bad textbook. Okay, while learning quantum field theory, you open Peskin, you want to give up high energy physics. Okay, do not do that, because Peskin is written for graduate students. They assume that you had a fantastic course in relativistic quantum mechanics. They assume that you had, a very nice course on understanding, metric spaces or manifolds or everything. So then it's that you are not ready for that textbook. Okay, you are not ready for that lecture. There is an extraordinary scientist and he comes to give you a colloquium talk, and you don't understand the topic. You do not make assumptions about the topic that, this topic sucks. It's just that you are not ready for it. Okay, so stop making opinions just because you had bad experience. The topic is obviously beautiful. I mean, millions and millions of people are working on it daily. That means the topic in itself is fantastic. Okay, so when you're reading for the first time, be a beginner and learn why that guy is telling that. If it's not working for you, some textbooks do not work, man. If there are people who immediately open Landau-Lifshitz statistical mechanics and think that all Russians are morons. But that's not true. Okay, Landau and Lifshitz are extraordinary scientists who revolutionized the fields of starting from fluid dynamics to quantum field theory. It's just that textbook is not written for you. Go back to Griffiths and learn in statistical mechanics. Go back to Reef. Learn things that are textbooks that are catered for that audience. Then build up, and do not form opinions early stage. If you are a researcher and then you claim that quantum field theory is non-rigorous, I'll take it. I know that quantum field theory is not rigorous, but as a beginner, you're not supposed to say that. I mean, you don't know why is it not rigorous. Just because just because I know the name of it, it's not enough to claim things that you understand it. Okay, so take in the pinch of salt in that way. Okay, not the subject itself. Okay.
Okay. Yeah. So
can I add a point?
Yes.
Yeah. So since Peskin and Schroeder was mentioned, I would like to point out that if you take an example of QFT, mostly introductory books start with Lagrangian. They just start with some Lagrangian and start quantizing. But actually, if you take Weinberg, Lagrangian comes in 7th or 8th chapter. So he tries to make sense of why do we use Lagrangians. So if you do not take the point that if you are not accepting why we are using Lagrangian and start reading Weinberg, then all the best for 1 or 2 years you'll spend in that book.
Yeah. So to conclude this question, I guess as Copernicus did with Aristotle, and as Einstein did with Newton, he just climbed upon the buildings that Newton, take the case of Einstein, he climbed upon the building that Newton made, and then blew its foundation right at the base so that the whole building collapsed, and he came down with a parachute or some kind of that. So, yeah, so moving on.
add one point in this one, just
Okay.
a small. So this approach which Ganesh and I talked about, that this accepting things first and then iterating back. Like there is an insider step that if you are studying a topic, do look up to German authors' books. So they tend to follow this kind of an approach. Most of the German authors. And this tip especially works for topics which are beyond undergrad. So, for example, for undergrad, there are excellent books from like all authors. But for graduate subjects, I think German authors do a great job in this kind of adapting to this kind of an approach. So, yeah.
Okay. So, moving on to the next question. We have fourth question as this is I guess this is very common with all of the students. You would relate it to like how do you deal with the conceptual doubts, and especially when nobody is around to discuss it in the growing era of pandemic and self studies. We are quite contained as a social being. So we would like to ask the panelists like what platforms are available to discuss such concepts, not just problems, because we as a cause community, and there are many other groups as well on Telegram which are there to discuss problems, but we do not have any immersive platform for concept discussion. Like it is not very possible to text and understand things. So what could be done? Over to Soumya. Soumya, can you hear us?
Yeah, hello.
Yeah, Soumya.
Yeah. So, this is the question which we face every day. So, the most common example of this question is while going through some proof, we are stuck on some step, like how the step from step 5 we have step 6. Right. This is the common example of the conceptual doubt. So what I do first of all, I write down my problem. That what is the exact doubt I am having. So this is the first thing which should be done. That sometimes we have doubts, but we don't have the clear picture or the clear example of the doubt. Right? Like this is necessary because when you are asking someone who is not with you and you can interact with your mother tongue, so you have to first write down the problem or the conceptual doubt with all the details, how this problem arises, what is the prerequisite. Then try to post this on some online group. Right? There are lots of online groups. Like for quantum information, there is a good book in Facebook. There is a good book in Twitter and group. And there are some other, that Facebook or online groups. So first of all, that writing down your doubt is the main thing. Right? And second thing, that
Feynman technique, right?
Sorry?
Sorry, Feynman technique, I meant.
Yeah. Yeah. So the second thing is, what I am telling that there are some, if your problem is on some basic steps of a textbook, you are most likely to find it in some Quora or the Stack Exchange page. So try to search there and try to have their opinion, right? So the most common, when I was reading quantum information, the most common, the conceptual doubt started the interpretation of quantum mechanics. What is the interpretation? The Bohm theory or the Copenhagen interpretation or the Pilot theory. So which one is the correct? Why this so many interpretations come? And these things. So these are the some conceptual doubt you have to deal. You have to search in the Google. You have to go through some of the go good lecture series on YouTube, because there are lots of, if you search any topic, you will find lots of lecture series. But particularly here, without clear, it's hard to find. So the main thing what I'm trying to point out, that write down the exact doubt you are having. Then this is the first step of solving that doubt.
Okay, that was good. Soumya, thank you. Chintan, would you like to add something to it?
Yeah, I mean, everything was mostly covered by Soumya. So, where mostly what I do if I have some doubt and can't ask anybody is to go through various sources, like various books or various lecture notes or some lectures. So, mainly it's probable that the book you are following doesn't explain that topic nicely. So if you follow through some other notes or something, you will get more insight into the topic, or a stack exchange is known to everyone for nice, rigorous, mathematically rigorous answers. So that's all.
Okay, Abhay, would you like to add, or I think everything is cleared up to this point?
Sorry to interrupt. Bhavya, you were telling that stack exchange and maybe a few other things were useful, right? The other day.
Yeah, physics exchange that Soumya already covered, I think.
Okay, all right. And one more thing to add is, if someone has a plan of implementing these things to discuss physics questions or stuff in the community itself, please direct message me or share somewhere in the group. One of our team members will get to you. If you have a plan, we can try to form such things where we can discuss a particular topic per week or something like that. We haven't planned yet, but yeah, if you are familiar with such models anywhere, we can do that. So on a good level. Otherwise, it's basically just like someone sharing a problem and then someone solving it for the interest or not. But we can have like proper discussion of the stuff altogether.
Adding to what Dushan said, we kind of can experiment on a notion that we could organize a meet where we could discuss these things on with the audio or video interpretations. So that would help beyond the chats and text. So yeah, guys, please do mention it if you find it interesting enough and want to join.
But I want to add one point, Adesh, here.
Yeah, Bhavya.
So as Ganesh told that you have to get comfortable with not knowing something at a particular stage and don't get anxious, because like it may be possible that whatever conceptual doubt someone is facing, that is resulting from a particular concept which the author does not have time to introduce. For example, very interesting example for this is when you are quantizing electromagnetic field. In that you have a very slightly different commutation relation. You don't really have iota h bar, but some factor of subspace is coming there. And authors try to motivate that kind of thing with all sorts of crazy hand wavy ideas that you are projecting it on some subspace because of gauge degrees of freedom and so on and so forth. But when you learn enough of the concepts, you tend to know that exact relation comes from constraint systems. And when you are quantizing constraint systems, you don't really quantize Poisson bracket, but you rather quantize Dirac bracket. And there are extra terms in Dirac bracket from which you get those factors, which authors tend to motivate by hand-wavy arguments, obviously because author don't have time to introduce those kind of things at that spot, because constraint system is again a whole different. So sometimes if you are having conceptual doubt, it's not because you are having a gap in your knowledge, it's because there is the gap in the standard presentation itself of the subject. And just get comfortable with that you have some gaps in your knowledge, and that will be covered, somehow will get covered in future when you will get more experience with the subject. So
Bhavya, what we usually do is like if something is not given in one book, we jump to another book with the same topic. So I think that covers, and that sometimes helps, but most of the times it confuses a lot. So
others.
yeah, Swami.
So I want to add some point that there will be some doubts which will stay with you forever. Yeah. So in quantum mechanics, as Feynman said, I want to live with doubt and uncertainty. So don't expect that all your doubts will be solved one day, or you are having some doubts. That does not mean you're a bad student. You don't want to. You will not do anything in physics or in career, right? So that is the point I am trying to make, that having doubt is a good thing. Some doubt may resolve, some doubt may not, right? So yeah, that is the thing. So
Yeah, so basically, we won't have anything to be curious for. Then what's the purpose of physics then? So that covers the this question.